Well, YouTubers and fellow hams, this is what I've got on the bench for this week's project. This is an Echophone EC1, or the Echophone Commercial, it says there. Interesting little side note on that. It looked so military that I think that they put, well, the speculation is that they put commercial on here so that people bringing it in and out of military bases wouldn't be accused of stealing gear. to denote this as a commercial product versus a military product. Anyway, this is the Echophone EC1 receiver. It's part of a class of receiver commonly referred to as the All-American 5, being that it was a 5-tube model, a simple super heterodyne design. There were several receivers, like the Hallicrafters S38s, that followed the same design principles and virtually the same layout. In fact, speaking of Hallicrafters, well, we'll get into that in the history in a second. This radio was sent to me by Phil from South Carolina. He picked it up somewhere, and he wants it recapped, electrically repaired and tuned up. I'm not going to do too much cosmetically because I really don't have the materials or the skill set to properly repaint the case and re-stencil all the labels, because these are painted on with a stencil over the existing paint. The existing paint's in pretty good shape. We'll take a closer look at that in a second. But first, let's take a quick look at the history of Echophone and the schematic of this radio. And then we'll take a close look at this particular specimen and see what we're going to have to do to it. So this is the Echophone Commercial that I have down on the bench. Echophone was a radio company way back in the 20s and 30s, I think, somewhere around there. They made early receivers, and they had licensed a lot of patents from RCA, which is kind of important in the history of the Echophone Commercial that I have downstairs. You see, in the late 30s, early 40s, a guy named Bill Halligan wanted to start building radios. And he wanted to build radios for hams to use. And this might actually have been earlier in the 30s. I'm not quite sure of the dates, but it's right around that time frame. So Bill, he tried to approach RCA to license their patents, because they had patents on a lot of radio design principles that he would have needed to use. And he was turned down time and time again. Well, he was a smart guy, and what happened was Echophone, who was making these receivers, they weren't doing so well, and they were going to go out of business. So Bill Halligan, he bought Echophone. Right at the time they were about to go out of business, he bought them, and he got the company for not too much money, and he got all of their licenses to use RCA's patents for radio designs. And that was what Bill needed to form Hallicrafters. Bill Halligan is the guy who started Hallicrafters. This is Bill here. And this is a photo with him and one of the Hallicrafters radio sets, people around him, probably demonstrating it. So he built Hallicrafters transceivers and transmitters and receivers for ham radio operators and for the military. But he also wanted to tap into the commercial market. And that's where the Echophone brand name came in. He started to build Echophone receivers for the commercial market, for the average Joe, for anybody to buy using their house to receive. And that's where the EC1 came in. He built this guy, and it was extremely popular. It was very popular amongst GIs and soldiers because of its size. It's so small that made it quite portable. And there were tons and tons of ads that were, well, you've got ads for people to use it at home, but their little mascot guy, Hogarth is what they called him, was a soldier. He had his little helmet, and ads that would definitely not fly today. Yeah, okay, he's sitting there smoking a hookah, And all the women are paying attention to him because he's got this Echophone EC1. And these Arab gentlemen back here, I guess that's the tie-in with the hookah, are upset because he's getting the girls because he's got an EC1. Yeah, these ads would not fly today. But anyway, the EC1, I think it was $19.95 back then, which, yeah, I don't know what that works out to nowadays, a couple $100. An affordable price for the average homeowner to pick up. So the radio was quite popular. So that's who was responsible for it. Bill Halligan of Hallicrafters made the EC1 to be a commercial radio for people to use at home. Now it is one of a class of what's commonly referred to as the All-American 5. Many popular receivers of the era had a simple 5-tube design, and this is the schematic for the Echophone EC1. And it's a very simple superheterodyne receiver. Single conversion superheterodyne receiver. That means it's got one IF stage. So looking at the schematic here, the input section, let me set myself up to outline things. The input section here is a pre-selector. There's 3 bands in the radio, so there's 3 tank circuits. And these are bandpass filters, or they're going to pass just a specific range of frequencies that you're interested in for that band, reject all else. And that's important. Otherwise, you've got everything coming into your front end, and the radio can be overloaded. So you've got a front end network, that's the pre-selector. This down here is the 3 tank circuits for the oscillator. It's a superheterodyne, so you've got a local oscillator that is 455 kilohertz higher in frequency than the frequency that you're interested in receiving. So if you're interested in receiving 1 megahertz in the broadcast band, these local oscillator is going to run at 1.455 megahertz. And this tube here, this 12K8, has 8 elements in the tube. This is doing dual duty. Part of it here is the oscillator, and then this top part of it is a mixer, where you've got your RF coming in from the antenna that's being mixed in with the local oscillator frequency, and what comes out of the tube then is the sum and difference. So one of those will be 455 kilohertz, which is the difference between the local oscillator and the frequency you're interested in. And then this is the first IF stage, first IF transformer here, which passes the 455 kilohertz, and that rejects out of band signals, therefore narrowing down the selectivity of the radio. And this 12SK7 is an amplifier that is amplifying the IF. It's the first IF amplifier, or the only IF amplifier in this case. And here we can see the standby switch. When this is in standby mode or opened, we don't have a ground, so this tube is effectively muted, cut off. It's not going to amplify. Same thing with the mixer and the oscillator. They're going to stop. The oscillator is going to stop, and the mixer is going to stop working because it doesn't have a ground when the standby switch is open. Anyway, IF amplification goes on here. Second stage filtering for the IF is here, this transformer. We've still got 455 kilohertz coming out with the amplitude modulated audio on it. And then we have our detector here. This 12SQ7. This is, again, doing dual duty. It is a couple of diodes and a triode tube. So the diodes are being the detector for the audio on the signal, rectifying it. And then that amplitude modulated audio is amplified. And the output of this detector amplifier goes to the audio amplifier, which is just a straightforward single stage amplifier. And its output goes through a transformer where you've got your phones and speaker. Now this is a safer radio than some of the older radios. The headphone jack is on the output side of the audio transformer, so it's isolated from the high voltages in the circuit. Some of the old receivers, the headphone amplifier was actually right off the plate of the audio amp. And if you plugged in headphones, you'd better be sure that those headphones are good, because you have the B plus voltage, the 100 and some or 200 and some volts coming out the headphone jack. You're not going to have it here because it's isolated by the audio transformer. So that's kind of cool. And there's our phones and speaker switch there. It's a pretty simple circuit, really. Not a lot going on. This one has a BFO, beat frequency oscillator, down here. And this would be tuned to be about 600 or 800 hertz off of the local oscillator frequency. Or off the IF frequency, sorry. So this would be at 455.6, let's say, if it was 600 hertz off. And when it's enabled, then it's going to beat with the IF signal that's coming in. So if you have a carrier-only mode like Morse code or single sideband, or not carrier-only, something without an amplitude-modulated component like single sideband or CW coming through, this generates a signal to beat against that carrier and produce a tone, and that's how you can hear CW. And here's the on-off switch for the BFO, which again, we're just enabling the other side of this circuit, or this transformer, to couple the signal in. Now you'll notice that this line coming out from the BFO is not connected electrically to anything. It's just loosely coupled into the IF circuit. And when I pull the bottom off the radio, I'll point that out to you, how that's brought in. The tuning capacitor over here, you can see it's ganged together. It tunes this tank circuit for the oscillator frequency, and it also works in conjunction with this with whichever filter circuit you have switched in. The second half of that tuning capacitor works in conjunction with that to tweak and tune the preselector filter along with the oscillator frequency. So as you're tuning across the band, the preselector is following, and the filter is following, so that you're passing the range of frequencies centered around what your target frequency is for the receiver. So that's how the Echophone works. Power coming in. We've got our AC line coming in. Hey, look, they even mentioned here polarized plug. I think this is an updated schematic. They probably wouldn't have said that on the original. But the line, the hot coming in, is switched to one side of the filaments. And there's a 220 ohm current limiting resistor here that then feeds it to the rectifier. And what comes out of the rectifier is your B plus high. So 120 volt half wave rectified AC is your B plus, and you've got 47 microfarad filter capacitor here to smooth that out and cut out the ripple. And there's your B plus line off into the circuitry, feeding 120 volts to everything. The neutral side is, it's got a capacitor filter to the outer chassis ground, but it is directly connected to the chassis ground here. Oops. All right, let me zoom in on that. So this is the neutral coming in. This is why you have to have a polarized plug. If you plug this in backwards and this line here was the hot, then you would have the 120 volt hot right to the chassis. And that's why they call it a hot chassis. Now the tubes are in series, so their total filament resistance voltage drop equals 120 volts. So these tubes all have to be properly matched and balanced so that their filaments will all draw about the same amount of current and glow at the same temperature and drop the 120 volts coming in. So no transformer, no power transformer on this radio. It's a very simple circuit. So there you go. That's the history and a look at the schematic on the Echophone. Let's go back down to the bench and take a closer look at the radio that we're working on. Overall, this radio is in pretty good shape. It's dirty. You know, these letters should be white, and they're kind of yellow. A little bit of a yellowish tint to the dial, probably from the plastic, which actually is kind of quaint. That might look kind of nice when it's lit up and turned on. It has all the original knobs, although the volume knob here is broken. I don't know if you can see this crack across it here. Somebody has glued it with epoxy, I think, which is too bad. I don't have another knob that matches. I could probably find one, but we're not too worried about doing a full cosmetic restoration on this guy. This knob is functional. The crack is right across where the screw is. The screw is on this side, so somebody tightened that screw in too tight and broke off the Bakelite knob. Other than that, everything else, the switches are pretty stiff. That's better. And the standby switch is better. So yeah, you can tell the speaker and headphone jack selector wasn't used very much. That's pretty tight. The plastic face is riveted on, and the switches are riveted on the front panel. So getting the chassis out of this is going to require desoldering the wires from these switches, I think. But we'll get into that when we start to do the electronic work. So it's a little dirty, but it's in pretty good shape. There's some scratches. Some scratches here on the top case. I think those are yeah, I can feel where the paint's gone, so that's got scuffed. There's a very faint stencil here. Somebody stenciled their name in it, which you could probably just start to see that on the camera. I think it says J.G. Berry. Was probably the original owner. Around the back, well, the sides here, we've got some more scuffs and scratches here, which is a shame. If I had the skill to do it, I would repaint the whole case, but I have to learn how to do that properly, and I'm not going to experiment on a customer's radio. So one of these days I'll pick up an old radio myself, and I'll bite the bullet and spend the time learning how to refurbish the paint. On the back, there's the inside of the chassis. It's in pretty good shape. There's a little bit of dust. It's not bad. There's no rust that I can see. It's just dirty and dusty. These speaker wires are badly disintegrated. I think that's just a plug. Yeah, that's just a plug there. Oh, the plug is broken. The phenol plug assembly is broken. That's unfortunate, but these wires are bare. The insulation's back off them, so I'm going to have to replace those wires on the speaker. Actually, this one's just looped on there. It's not even soldered. The top, where the speaker is, comes off. There's 6 screws, 3 on either side. Let's go ahead and pop that off so we can get a better look at the tuning deck. There's our speaker. Cone looks good. No tears. It's probably fine. That's good. Put that aside. And here is the tuning deck. It's dusty and dirty, but it looks to be in fairly decent shape. Just needs to be cleaned up and lubricated. Probably the tuning assemblies, the bearings on the caps. And we'll just have to clean all that dust out. So the wires that come up to the lamp for the dial, we'll test that. And they are cloth covered, but they don't look like they've disintegrated. They look like they're okay, just a little dusty. So a little bit of dirt and dust, that's not too bad. Somebody has already replaced the power cord with this big, ugly, way oversized 3-prong cord, and they didn't even hook up the ground wire. They've just got it floating. So we're going to replace that power cord. I might put a 2-wire cord with a polarized plug in, put it back like it was. This radio has what's called a hot chassis. You'll notice there's no big power transformer in here. We've got a small audio transformer for the speaker, but no big power transformer. The way these radios were built, the AC came in, all the tubes are in series, and their filaments are chosen specifically so that the complete voltage drop across all of those in series is 120 volts. It's like the old Christmas tree light bulbs, where all the bulbs were in series. And if one of the filaments opens up, they all go dark, and you've got to test them all to find out which tube is bad. And then the 120 volts from the line is the high voltage for the tubes. It's just rectified. I think this is the rectifier, or this is the rectifier. One of these two is the rectifier. They're so dirty I can't see the numbers. Rectified and filtered, and then that provides your B plus for the tubes right off the line. And the neutral wire on the line cord is attached directly to the chassis. So you need a polarized plug, because if you plug that plug in backwards, then the hot is on the chassis, and from here to ground you have 120 volts, and it's a shock hazard. So these old radios were a little dangerous because of that. You know, you had to be careful about how it was plugged in. The outer chassis is isolated from the inner chassis with rubber grommets where it's mounted. We'll see those when I take the bottom cover off. And the tuning capacitor is isolated from the main chassis with rubber grommets under here, so I'll have to take a close look at those. I might have to lift this off to replace those if they're breaking down. Alright, let's take a look at the bottom. And you'll notice I've got a towel down here on the bench. Don't want to scratch the paint any more than it already is. The bottom chassis is held on with 1, 2, 3, 4 screws. Those are 1/4 inch hex head. I'll have to get my nut driver out to take those off. Let's see here. And there is the guts. Oh, it looks like it's all original. All these original capacitors. Yep, it's all original. That's cool. So all these old wax capacitors have to be replaced, because they're all going to be leaky. And these old electrolytics here are going to be replaced. So that's, definitely we're going to have to do those. There's lots of resistors, old resistors, that I'm going to measure and check, and I might have to replace several of those, because I bet some of those are way out of tolerance. It's okay if they're a little bit out, because the radio is pretty simple, but if they're way out, they're going to have to be replaced. And there's some modifications that can be made that will quiet the radio a little bit too, so I'm going to make those, and some things you can do to protect, like the antenna coil. Mr. Carlson's lab has a really great restoration and tune-up video for this radio. I'll link it in the description below. It's going to be far more comprehensive than mine. I'm going to film a little bit of what I do inside of here, but and I'll film the alignment for you. But that'll be in part 2, where we really go through it. So this electrolytic is mounted down here with a rivet. I'm probably going to drill that rivet out to get this cap out anyway. I might put a fuse holder in there and fuse the incoming hot. Here's the hot here. Goes right here to the rectifier. So that would be fine. I'll put a fuse holder right there, and we'll fuse that incoming line. The old cloth-covered wires all look like they're in pretty good shape. As long as I don't disturb what I don't have to disturb, I won't have to replace any of those. This is interesting. You see, I don't know if you can see right here. Let me zoom in. Okay, right here, you see how this wire is wrapped around this wire that goes up to the tuning capacitor? That is the BFO injection. The beat frequency oscillator output is just wrapped around here. It's not electrically connected. There's the end of the wire right there. And that's how they inject the BFO signal into the IF chain. They just just loosely couple this wire wrapped around that other wire. Neat. So, it looks like I got some work to do here. Lots of capacitors to replace, maybe a few resistors to replace, and a power cord to replace. And once we get all that done, we'll be able to power it up and align it. So that's the evaluation. Oh yeah, the rubber grommets. Yeah, they're cracking and falling apart. Alright, so I don't know if we can see these, is one of the rubber grommets that keeps this chassis isolated from the outer case, and it's cracking and falling apart, so I'm going to have to replace those grommets. That's not going to be fun. To get the chassis out, I'm going to have to desolder there's one of them, you can kind of see it. Here's one of the front panel switches. Remember I said they're riveted to the front panel, so I'm going to have to desolder the wires for that switch. There's one up here, and then there's the one up at the top of the chassis. So I'll mark and label those wires and take a photograph before I remove them. And we'll get the chassis out to work on it, and yeah, I guess that's what I'm doing this week, is replacing parts. So, part 2 of the video on this Echophone will be the actual electronic work and the alignment. And look for that maybe next weekend. It's going to be a slow project for me. I have a real hard time getting anything done after work through the week because I'm so wiped out at the end of the day, but we'll do what we can. And we'll get this old radio singing again like it was new. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.